we have to supply energy then. From outside. Now we can supply energy from outside in various methods, like heating the metal. You can see this. I'm just giving an overview of the last class so that you can continue today's class. So we can have, by giving heat energy, that means heating the metal, we can provide energy to the electron, which is sufficient. When the energy will become sufficient, then the electron will come out of the metal. You have to overcome the potential barrier. The minimum energy required for an electron to just come out of the metal surface without any kinetic energy is called work function of the metal. The minimum energy, the minimum amount of energy required by an electron to just escape from the metal surface with any without any kinetic energy is called work function of the metal. Okay, so just the work function is just equal to the potential barrier. You have to what you have to do to overcome the potential barrier, that is your work function. Okay, so you can provide energy by heat, you can provide energy by some electric field, you can provide energy by light photons, and also you can provide energy by some primary electrons. Okay, accordingly we have.
So basically work function is the energy required to remove that electron, right?
Yeah.
Okay.
Now electron emissions can be done using by heating the metal, which is called thermionic emissions, and emitted electron is called thermoelectrons or thermions. Or we can use electric field. That electric field will pull out the electrons. That emitted electron is called field electrons, but here we need very large amount of electric field. Photoelectrons, so when electromagnetic radiations incident on the metal surface, the energy of the radiation was absorbed by the electrons. When they get sufficient energy, they will come out of the metal surface. And electrons emitted in this way is called photoelectron. And the other method is secondary emissions. We will send some high energy electrons, fast moving electrons. When it will collide with the free electrons, then it will transfer a portion of its energy to the free electrons, and the free electrons may be able to overcome the potential barrier and to come out of the metal surface. And this type of emission is called secondary emissions, and the electrons emitted in this way is called secondary electrons. Now our concern is only photoelectric effect. There are different experiments. In 1887, during the Hertz experiment, Hertz found that when what I say, Hertz found that if you can remember that Hertz setup, there are two metal plates in the which acts as a capacitor. Now, if these plates are illuminated with light, then extra spark is observed at the detector. So whenever these plates are illuminated with suitable light of suitable wavelength or frequency, then some electron will emitted from these metal plates, and they increase the field. They will increase the fields, electric fields, and enhance the electric spark. Also, there are some experiments done by Haloich and Leonard. They used a zinc plate, and they use UV light, then some electrons will come out, photoelectrons, and it will become positively charged. Now, if it is initially uncharged, then it will become positively charged, and you will see some deflections of the gold leaf. Now, if it was positively charged, then it will become more positively charged. So the further deflection of the gold leaf will be noticed. If it was initially negatively charged, then after hitting this UV light, it will become less negative, and the deflections will become smaller. Okay, so in this way we can understand that we can get the existence of photoelectric effect. Is Leonard experiment, which also shows whenever UV light hits this cathode, some current will register in the circuit, which supports the intention of photoelectric effect. Then there are some experimental study. This study was carried out by Leonard and Millikan. They have used this type of setup. This is a glass bulb with a quartz window. This is a cathode. This is the anode. When light of suitable frequency incident on the cathode, some electron will come out, and this anode is at some higher potential using this potential divider circuit, so that this electron will be accelerated towards the anode, and we will register some current, and the voltage will be measured with this voltmeter V. Okay. Now we have studied the effect of different parameter. First, effect of intensity of light. Now radiation of fixed frequency, the acceleration potential difference A, that in frequency and the potential difference both are remain constant. In this condition, if we plot the photocurrent as a function of intensity of light, then you will see as the intensity of light will increase, photocurrent will increase linearly. Photocurrent will increase linearly. Now, number of photoelectrons emitted per second is proportional to photocurrent. That means it is proportional to the intensity of incident light. Okay. Number of photoelectrons emitted per second is proportional to the so number of photoelectrons emitted per second is proportional to the intensity of the used light. Okay. Up to this is okay. Do you have any doubts?
No, I understood.
Okay. Now, if we see the effect of potential, accelerating potential, then it is found that with positive accelerating potential, the current initially increase, then it will become maximum value and it will remain constant. That is a saturation current for a specific intensity. If you increase the intensity, the saturation value of the current will also increase. Okay, but when we go in the negative directions, that means we will change the directions of the accelerating potential. When we apply some decelerating potential, then we will find that current, whatever may be its intensity, current will stop after, say, some stopping potential minus V naught. So this potential, when current will become zero, is called stopping potential. Current zero means we can say that electron with highest kinetic energy is unable to reach the anode. Okay. Current zero means electron with highest kinetic energy is unable to reach the anode. That is why current is zero. That means the maximum kinetic energy, which is equals to half mv max square, should equals to E into V naught. There is a relationship between the stopping potential and the kinetic energy. Now, for a given frequency V naught, independent of intensity. So kinetic energy is independent of intensity. It depends only on the frequency. The maximum kinetic energy of the emitted electron do not depends on the intensity of the incident radiation. So maximum kinetic energy is independent of intensity of incident radiation. So it depends only on the frequency, not on the intensity. Okay. Then we will discuss the effect of frequency. Just wait for 1 minute. So if we study the effect of frequency, what we have do, we have used different frequency, okay, and we have adjusted the intensity in such a way that for each frequency we will get same saturation current. For each intensity we will get same saturation current, okay, but for different frequency, the stopping potential is different. As we increase the frequency, stopping potential is decreasing. That means magnitude of stopping potential is increasing, but it is increasing in negative direction. Okay. So stopping potential, which is proportional to the maximum kinetic energy, that is also, that means maximum kinetic is proportional to frequency. So maximum kinetic energy is dependent on the frequency of incident radiation. Now, if we plot the stopping potential as a function of frequency, you will see that above threshold frequency, there is a linear variation, and below this threshold frequency nu naught, there is no emission. So there is a cutoff frequency above which electron emission is possible. For this cutoff frequency is different for different material, but for each and every material, there should be some cutoff frequency. This cutoff frequency is somehow related to your work function h nu. For different metal, cutoff frequency is different, but the nature of the graph is same. So if the incident frequency less than the minimum cutoff frequency or the threshold frequency, there will be no emission of electron, because you need minimum that amount of energy of the photon, which is equals to h nu naught. However large may be the intensity, if the cutoff frequency is less than the cutoff frequency, no emission will be possible. No emission will be possible. And this photoelectric emission is instantaneous. The lag between incidence of light and emergence of electron is of the order of 10 to the minus 9 seconds. So in microsecond order. So it is instantaneous effect. Based on this experiment, we have accumulated 4 laws. One is for a given photoelectric material and frequency of incident radiation above the threshold frequency, obviously, the photoelectric current is directly proportional to the intensity of light. The saturation current is directly proportional to the intensity of light. If intensity increases, saturation will also increase. Secondly, for a given photoelectric material, there exists a certain minimum or minimum cutoff frequency below which no photo emission is possible. However, howsoever high the intensity is, okay, so there always exists a cutoff frequency, which is called threshold frequency. Above threshold frequency, the stopping potential or equivalently the maximum kinetic energy of the emitted electron is directly proportional to the frequency of the incident radiation. So above cutoff frequency, the stopping potential or equivalently the maximum kinetic energy of the kinetic energy emitted electron is directly proportional to their frequency of the incidental um, uh, So stopping potential, that means maximum kinetic energy is dependent on the frequency, not dependent on the incident. And fourth and final law, the photo emission is an instantaneous process. The time lag between the incident of radiation and emission of photoelectron is of around 10 to the power minus 9 seconds. So it is below picosecond. Now, classical wave theory completely fails to explain the photoelectric effect. Now, according to the wave theory, light is an electromagnetic wave consisting of electric and magnetic fields with continuous distribution of energy over the region which the wave exists. Okay. Now, the wave theory could not able to explain the basic features of the photoelectric effect. According to wave theory, the wave front strikes the metal surface. The free electron absorbs the energy continuously, gathers the intensity, greater the amplitude, greater the energy density. Hence, higher intensity should liberate photoelectrons with greater kinetic energy. But contradictory experimental result has been obtained. According to the experimental result, the maximum kinetic energy emitted per electron is independent of intensity. Wave theory fails to explain the existence of threshold frequency. Why threshold frequency would be there? According to the wave theory, no matter what the frequency is, light wave sufficient having sufficient intensity over a sufficient time interval should be able to impart enough energy required to eject the electron from the metal surface, required to eject the electron from the metal surface. But it has not found. What we found, when light incident, only at that time some metal particle will go out of the metal surface. That may also be possible. Wave theory fails to explain the instantaneous nature of the photoelectric effect. According to wave theory, it will take finite time, so the electron will get sufficient energy to overcome the potential barrier. Now, according to wave theory, the energy distribution of a wave is smooth and continuous. Okay, and the and evenly distributed across the advancing wavefront. Now, each electron incident can insignificantly small amount of that energy, so almost so it should require a finite time to escape from the metal surface. Okay, one electron is gathering very small amount of energy, so we need extra energy. We need it has been experimentally observed that the method is the instantaneous. So we have to search for some new mechanics in this point. Just trust him. So up to this we have started in the last class. Which shows that classical theory is unable to explain the photoelectric effect. For that, we need some other theory, some new theory. This new theory is given by Einstein. Just checking if the attachment has completed or not. Yeah. I have sent you one mail. Please check it, whether you got or not.
Yes, I got it.
Please check whether the video is opening or not.
So it's showing the video cannot be played.
Video?
The video cannot be played.
Video cannot
It's
be played.
showing that. Yeah.
Just wait. Can you download the video?
So there's not enough space on my phone. I'll try it on my laptop.
You have to try it on the desktop. Okay.
Yeah, that's what I'll try it on my laptop. Yeah.
I'm sending you another 2 files. These two may require for playing the video. These are small size file. One is audio, other is some supporting file. If it is unplayable, then report me, then I will upload it in the YouTube and send the YouTube link to you.
Okay, it's showing it will take a lot of time to download. So once it's done, I'll let you know.
If you download it, if you can able to play it, okay.
Okay. If I'm not able to see the video, then I'll let you know.
Yes. And then I will upload it in the YouTube and we'll send you the YouTube link.
Okay, sir.
Now, Einstein theory of photoelectric effect. Okay. Now, when this classical theory fails to explain the photoelectric effect, then people tried something different, have to try. At that time, the Planck theory of black body radiation was there. Einstein used that concept of Planck theory of black body radiation, in which it has been stated that radiation energy is in form of energy packet. It is not continuous. So in 1905, Einstein explained photoelectric effect on the basis of Planck's quantum theory. Now, according to Planck's theory, a light radiation electromagnetic radiation travels in the form of discrete photons. Now, energy of the each photon is equals to h nu, when nu is the frequency of the radiation. It can origin also as h slash omega. H is known as Planck's constant. Nu is the frequency of radiation. So you can understand the energy of the photon is dependent on the frequency. Why we are getting that type of result in photoelectric effect. Now H dash is equals to H by 2 pi. This is known as reduced Planck's constant. And omega is equals to 2 pi nu. This is known as angular frequency. The main points of the Einstein theory of photoelectric effects are: photoelectric emission is the result of interaction of two particles. Photoelectric emission is the result of interaction of two particles. Which two? One, a photon of incident radiation and the other is an electron of photosensitive metal. Okay. So photoelectric emission is basically interaction of two particles. Here we are considering light or radiation as a flow of massless particle. According to Huygens wave theory, that light is a wave, then Maxwell shows that light is an electromagnetic wave. And the wave nature of light has been um, verified in different experiments like interference, diffraction, polarization, and also you can explain the phenomena like reflection, refraction, dispersion using the Huygens wave theory, the wave nature of light. So there is no doubt that light is wave light. There is no doubt in it. But there are certain experiments like this photoelectric effect, also the black body radiation, uh, also Compton scattering. So in this type of experiment, it has been found that wave characteristics of light cannot explain this experiment. Then Planck initially given that formula that initially given that idea that light consists of at least light wave when incident or emitted, when absorbed or emitted by some material, then it is absorbed or emitted in form of photons. Einstein has further said that not only they absorb or emitted, they also travel in the medium in form of photon. And this existence of photon was detected. Basically, it has been already detected. Photon is already detected, which is a boson. So you are getting some experiment in which light behaving as wave, and also you are getting some other sets of experiments in which light is behaving like a particle. So there till yet there is no such experiment which can detect simultaneously the two nature of light, both particle character and wave character. So in certain situation, light behave as wave, and also in certain other situation, light behaves as particle. So we can say light has dual character, dual nature. Okay. Now, according to Einstein's photoelectric theory, the photoelectric emission is a result of interaction of two particles. One is photon of incident radiation, other is the electron of the photosensitive material. Secondly, the free electrons are bound within the metal due to restraining forces on the surface. the free electrons bound within the metal due to restraining forces on the surface. The minimum energy required to liberate an electron from the metal surface is called the work function. The minimum energy required to liberate an electron from the metal surface is called work function. W naught of the metal. Work function is characteristics of metal. For different metal, work function is different. Also, it depends on the surface property. Thirdly, each photon interacts with an electron. Each photon interacts with an electron. The energy h nu of the incident photon now this energy is used up in two parts. One, first part of the energy of the photon is used in liberating the electron. In liberating the electrons from the metal surface. That is, this energy is used up to overcome the potential barrier or to cross the work function. Okay, which is equal so the energy out of total energy, this W naught amount of energy is used up to overcome the work function of the metal. And the second part, the remaining energy of the photon is used in imparting kinetic energy to the ejected electron. The remaining energy imparting kinetic energy to the ejected electron. So this is metal. Some photon will incident on the bound electron. The electron will come out with some energy and go in this direction. This is a photoelectron. This is H nu, the incident photon. And this is the bound electron. Fourthly, very few of less than 1% of the photons whose energies are greater than W naught are capable of ejecting the photoelectron. Very few, less than 1% photons whose energies are greater than W naught are capable of ejecting the photoelectron. Now, by the conservation of energy, energy of the incident photon is equals to maximum kinetic energy of the photoelectron minus plus work function. So H nu half mv max square plus work function. So K max, maximum kinetic energy, which is equals to half mv max square is equals to H nu minus W naught. So total incident energy minus the work function gives you the total kinetic energy of the photoelectron, emitted photoelectron. Now, if nu naught is the threshold frequency, then work function is equals to H nu naught. So you can write K max is equals to H nu minus H nu naught. or h into nu minus nu naught. Now these two equations, one is Kmax equals to h nu minus, this is 1, and this is equation 2. These two equations are called Einstein photoelectric equations. Equation 1 and 2 are called Einstein Einstein's photoelectric equation. And this equation can explain everything. Just wait a minute. Effect of intensity. The increase of intensity means increase in the number of photons striking the metal surface per unit time. Increase of number of photons striking the metal surface unit time. According to wave theory, intensity is the square of the amplitude and is the measure of the energy of the wave. But now Einstein proposed, according to particle nature of light, intensity is just the number of photons, measure of number of photons per unit striking the surface per unit time. It is not related to the energy of single photon. It is related to total number of photons. Now, each photon ejects only one electron. Each photon only one electron. Electrons either absorb that energy or will not. Okay, it is not possible that electron absorb two photons, then go to the higher energy level. No. If one single photon is sufficient to take it to higher energy level, only then it will absorb it, otherwise not. Is it understandable?
Yes, sir.
So each photon ejects only one electron. So number of ejected photoelectron, so increase of intensity means increase of number of photons, which means increase of number of photoelectrons, hence increase of photocurrent. So we have seen that photocurrent increases linearly with intensity. So this is the reason. Secondly, explanation of threshold. Which was also not explained on the basis of wave theory of light. Just a minute. This threshold frequency, why threshold frequency will be there, that cannot be explained on the basis of classical theory. Now, according to Einstein theory, Kmax is equals to half mv max square is equals to h nu minus nu naught. Now, if nu is less than nu naught, then Kmax is negative, not possible.
Hello.
Yes.
Yes, sir, I was getting disconnected. My data is slow,
Yeah,
that's
yeah.
why.
Just a minute. So Einstein theory is able to explain the threshold frequency, existence of threshold frequency. Kmax is equal to H into nu minus nu naught. Now, if nu is less than nu naught, then maximum kinetic energy will become negative, which is not possible. So that means no emission when okay. Thirdly, explanation of kinetic energy. Now, if nu is greater than nu naught, then Kmax is equals to half mv max square is proportional to nu. That is, above the threshold frequency, the maximum kinetic energy of the electron increases linearly with the frequency nu of the incident radiation. Moreover, the increase in intensity so it has been found above threshold frequency, kinetic energy increases linearly. Now, increase of intensity will increase the number of photoelectrons emitted per unit time. That is, it will increase photocurrent, but not the energy of the electron. Intensity has no effect on the energy of electron. It can only increase the photocurrent. That means number of emitted electron per unit time. But energy of the emitted electron does not depend on the intensity, it depends on the frequency. And fourthly, explanation of time lag. Photoelectron emission is instantaneous. If nu is greater than nu naught, photon will be absorbed by electron as soon as it reaches the electron. As soon as the electron absorbs the photon, it will come out of the metal surface. So this process happens very quickly. So the emission is instantaneous. So this is photoelectric effect. Let's have one or two quick problem. I've sent you two problems. Do them.
Okay, sir. So for the first one, you already sent the solution.
Yes. For the first
For
one.
the first one, you already sent the solution.
Okay, no problem. Do not see the solution. Just do the problem.
Okay. So is this first one 16 into 10 to the power 15 hertz? So
Yeah,
is the first one 16 into 10 to the power 15 hertz?
yeah. Have said.
And the
Oh,
third
sorry,
one,
sorry,
yeah,
sorry.
and the
At that time, I was muted. Third one, yes, third
oh,
one.
and yeah, third one, the energy I got 39.78 into 10 to the power minus 20 joule. And the number of photons, that one, that is 0.05 into 10 to the power 17 photons per second.
Yeah. Okay, correct. Both the problems are correct.
Oh.
Now, as I mentioned, the Einstein's theory that shows the particle nature of light, the photon. So, photon picture of electromagnetic radiations, the observation of photoelectric effect, clearly it indicates that when light interacts with matter, it behaves as if it was made of discrete packets of energy. So photon is basically packets of energy. Okay. In as you can find packet of water, and also you can have continuous water. River is flowing continuously in the water is flowing continuously in river on sea. But when you are getting packets of water, these are discrete. Similarly, photons, electron radiation, when interacting with matter, they behave like packets of energy, discrete packets of energy. And these each quanta of this energy or electron radiation is called photon. So there's this minimum building block. Quanta means minimum building block, which is called photon. So each quantum of light has an energy of h nu. Just a minute. So each photon, so it has been considered that when electromagnetic radiation interacts with matters, behaves as it was made of discrete packets of energy called quanta. Quanta is a plural term. Now each quantum of light has energy h nu, which is equals to h plus omega, and it has also momentum, which is equals to h nu by c. So though it has no mass, it has momentum. This is surprising. Our earlier definition of momentum is mass into velocity. It does not work here. The fact that a light quantum has definite energy as well as momentum allow us to associate a particle with it. Light quantum has definite energy and momentum. Allow us to associate a particle with it. So this particle was called photon. The particle nature of electronic radiation was further confirmed in 1924 by experiments of Compton's by scattering of X-ray of electrons, X-ray by electrons. The phenomena of increase of wavelength of X-ray photons scattered by striking electrons is called Compton effect. Einstein was awarded Nobel Prize in physics for his contribution to theoretical physics and the photoelectric effect. So there are some basic features of photoelectric effect which we have already discussed. Let us summarize them. In the interactions of radiation with matter, radiation behaves as if it is made up of particles called photons. Each photon has energy is equal to h nu, and momentum p is equal to hc by lambda, h nu by c, or hc by lambda. H each photon h by lambda, and its speed is c is the speed of light in free space. All photons of light of a particular frequency or wavelength have the same energy. So all photons of a particular light having same frequency nu or wavelength lambda has equal energy h nu. Photons are electrically neutral and are not deflected by the electric and magnetic field. This is very important, and this is why its discovery is delayed. Photon is neither deflected by electric or magnetic field. Is not deflected by the electric or magnetic field. It is a neutral particle, electrically neutral. In photon particle collisions, the total energy and the total momentum are conserved. In photon particle interactions, total energy and total particle momentum is conserved. However, the number of protons may not be conserved in a collision. Total energy is conserved, total momentum is conserved, but number of photon may not be conserved. The photon may be absorbed or new photon may be created. So number of photons will not remain conserved, but total energy and total momentum will remain conserved. Okay. And lastly, if the intensity of light of a given wavelength is increased, there is an increase in the number of photons incident on a given area in a given time, but the energy of each photon remains the same. Energy of photon can only be increased by increasing the frequency. We can use the photoelectric effect for determination of Planck's constant and work function very easily. What we have to do, now according to Einstein's photoelectron equation, the maximum kinetic energy K max is equals to h nu minus omega naught. Now, if this V naught is the stopping potential, then K max is equals to EV naught, which is equals to h nu minus omega naught, or V naught is equals to h nu by E minus omega naught by E, or V naught is equals to h by E into nu minus omega naught by E. Now, it is an equation of straight line, y equals to mx plus c. If we plot stopping potential as a function of frequency, it will go like this. For the slope of the curve, is given by delta V naught by delta nu, which is equals to h by E. So h equals to m into E. If we multiply the slope with the electronic charge, we will get Planck's constant. The Planck, after getting and from the intercept which is given by minus W by minus W by W naught by E. So W naught is equals to E into magnitude of the intercept on vertical axis. Magnitude of the intercepts on vertical axis. So in this way, the work function can be calculated and also the Planck's constant can be calculated for a given material. Now, by measuring the slope of the graph for sodium and using the known value of E, Millikan precisely determined the value of H and W naught for sodium. These values agreed well with the values known from other experiments. Thus, this led to the acceptance of Einstein's particle or photon picture of electronic radiation. Millikan was awarded Nobel Prize in 1923 for his work on determination of E and photoelectric effect. Now, using photoelectric effect, we can use the photoelectric effect for various applications, like photocell. There are three types of photocells: photoemissive cell, photoconductive cell, and photovoltaic cell. We will discuss it one by one, and also you discuss the applications of photocell. Then we will discuss about dual nature of matter. Here we are discussing dual nature of wave. That wave is behaving as material particle, but material particle will also behave as wave. That we will discuss in the next class. That very small portion is left. Photocell, application of photocell, and dual nature of light. That means the Broglie's theory. That we will discuss in the last class. Oh, you have Compton scattering also. No, sorry. This is the experimental evidence of electronic wave can be determined. It is a very famous experiment, which is called electron diffraction experiment. That will end the chapter. So in the next class, we will complete this chapter. Okay.
Okay.